then we could already start with some new functionality to our big integer class. So now I have one question for you. Who would like to implement the following functions? So since toHex and fromHex have been tasked as homework, I was thinking it would be nice if we could during the lecture implement toBin and fromBin, which is in a way simpler. The idea of those two functions is to convert from a binary, so from just 1 0 0 1 1 0 and so on, to our big integer back and forth. So that would be a useful addition to the functionality of our class, and especially in some use cases this is quite a useful thing. So one example, for example, where big integers are used aside of cryptography is in distributed networks to compute IDs of nodes, and since you want the network to be large enough to never run out of IDs, so then with a 128-bit number, for example, you are pretty guaranteed for this never to happen. And in such networks, you would do, for example, the XOR operation to compute the distance between two different nodes, or between a payload and a node, if we are looking for something, or if we want to store some payload. And for this, it's always so it is customary to represent the addresses as binary, since then, especially with the XOR metric, you can kind of, even with your eye, find out how close two addresses are to each other. So this type of network is called the Academia network. Academia is a subtype of a more generic network structure called a distributed hash table. And what makes Academia is that for the metric it uses already mentioned XOR operation. So if you have an address that looks like, I don't know, then let's make another address which is different at some point. Then basically the more, so the closer they are, the more bits they have in common. So this would be quite far away. If we would have an address like to the first one, if we would have an address like this one, that would be closer. That would be further away, and so on. And if you have the binary representation, then you can just more or less count from the left how many matches you have between the two. Sorry, from the right how many you have, and the more matches you have, the closer it is. And of course, if it's the same one, so you have all the matches from the left, then it's identical. If you're just missing one, for example, then it's almost close. If you are missing, for example, or like this, then you have a match until here. So it's quite easy to determine the distance, and that would be the use case why we would want, for example, to convert a large integer to a simple binary sequence. So who of you would like during the lecture to try implementing those functions? I will start the screen sharing. Sorry, the remote access. The screen sharing is already running.
I ask a question about
Yes.
Previous one we wrote the detach function.
Yes.
You said that it could be the case when we have a race condition when the detach happening at the same time another thread is calling attach. I think it may happen after you already deleted the pointer.
Well, the way it's implemented, so since we are using here this fetch subtract, then we can basically not run into a situation where they would become asynchronous, because here we are basically checking. So we are first subtracting our reference and then checking whether in that moment when we subtracted the reference, our reference, the value was 1, because this means the value now is 0, and this is done atomically. So no other program can at this moment break into our execution. And if we are doing attach, where it is here, we are increasing the reference count. And if we would do this without any sort of synchronization on the same object, so if we would have just one instance of big int, which is shared amongst two threads, so shared by using a pointer to it instead of just copying it. In this case, you're right, we could have a problem because we only have one in the reference counter, and we can pretty much, so we start execution here, we ignore this, we start execution. At this point, this one does its the referentiation. It still sees that it is 1. We are somewhere here. Then it tries deleting, and then here we try incrementing once we are already past this point. But this is why I mentioned last time that if you want to share one instance of big int, you need to have some synchronization external to big int. So if you have a pointer to big int and multiple threads are accessing it, you need some external means of synchronization to ensure this condition doesn't happen. But if we are just using big int, like just using full copies of big int, so we are not using unsynchronized pointers, then if you would want to call attach, then you are in one thread, and then just only this thread has a reference to this thingy. So you cannot call detach, it cannot be called at the same time. And if you would have another thread which would have a copy of big int, then the reference here would be already at 2. So if you are making your own copy in one thread, then you are increasing from 2 to 3, while this is decreasing from 2 to or 3 to 1 or 2. And you always have this value, the value returned being greater 1. Being unequals 1. So you never run into this delete block as long as you have more than one instance. Was that clear enough?
I just didn't really get the difference. If we call the detach twice, isn't it like, would it happen?
Well, how would you call detach twice?
From two different threads.
Okay, but then you have two scenarios. Either each thread has their own instance of big int, which both are sharing one instance of my pointer, or you have two threads, and you have one instance of big int to which a pointer is shared amongst these two threads, right?
Okay.
And if we have two pointers, so if we have one instance of big int and two pointers pointing to it, then we need external synchronization. Then just deleting it or doing something that might call detach is not safe. But this is something that you need to take care of in your code. If you have pointers and point to some objects, then you always need to take care of synchronizing these accesses properly. What we care inside big int is only the internal part. And so, for example, the case where you have two threads, each has a full instance of big int, but they are sharing the pointer. And if they are sharing it, then detach works safe, because as long as you have the two instances and one of them is doing detach, then this will never run down to 0. And if both kind of try to do detach at the same moment, one will get 1 and the other one will get 2. So one will do the deletion and the other one will not do anything. So this will work just fine. Did this clear up the confusion?
Yeah, thanks.
Okay. Any more questions? No more questions? Then we come back to my question. Who would like to do the first during the lecture assignment and implement these two functions? I think the connection should work the same one as last time, so the IP should not have changed. So you should be able to connect. I do not remember the password, so if one of you remembers it, that's fine. Else I will just change it again. I think, what was it? I think it was this one, or maybe with the second two letters being lower ones. So who is interested in doing the first exercise, or do I need to pick someone? Well, then I guess I will have to pick someone. Since Mr. Tim was already, I think, the last time doing something, so this time, Mr. How about Mr. Leonardo?
I'm not sure I'm gonna be able to do it.
Okay. Who feels like he might or she might be able to do it? I think we only have his here, but political correctness demands of us to always mention everyone. How about Mr. Kevin?
To be honest, I think I won't be able to do it because this is my first course in programming.
Okay.
So that might be a little bit. Ooh.
Well, since Tim did it so well last time, how about Mr. Tim?
I can give it a shot.
Okay.
But
Let's try it.
I would recommend anyone else to go for it as well. I know this is kind of odd being online and then programming, but being wrong is the best way to learn. And I'm most likely going to do it wrong as well. So the whole point of it is to just go for it. So if anyone else wants to, feel free.
Yeah, so don't be afraid if you don't know where. So if you just start and don't know where to go, I will guide you. So the idea is not like homework where you have to do it on your own. The idea is explicitly to see how far you can go on your own and then get guidance at the exact point where you don't have an idea how to continue. So.
Right.
So who would like to?
I can try.
Okay. Perfect. Then connect to the virtual machine. I hope if you don't remember the IP, I can check it quickly. So alright, and the port was different. So that was the IP, and the port was, I think, 5100. I think that was the right string to connect. I will quickly just check whether the port is the right one. Not one. Nope, the port is wrong. 690. That's the right. Okay, so try this port and IP and port. And if it works, then good. If it doesn't work with the password, then I'll change the password because I'm not sure about the capitalization of the one I used last time.
So for me, the password didn't work. The password didn't work.
Okay, then I'll just set it again. Okay, try now. Yes. Very good.
Okay, could you remind again what should I do with the function?
So the idea is that the first, let's start with the upper function. That's the easier one. So the idea is to create a string, a white string, which will contain the binary representation of our integer. So just zeros and ones. And the general way how one would do that is you would need two loops. One loop that goes. So if we quickly look to the header. Oops. Mouse sharing is not perfect on Windows. Can we just connect it? Okay, we cannot drop it in. We have to close it. So if we go to the header, we remember that we have this chunk
Mhm.
type, which in our case is unsigned long, in which we are storing the content of our number, but we have like multiple of those. So we have an array, and usually we have
Mhm.
more than one. So we need the outer loop that goes for every chunk in the array, and then within this loop we need the inner loop, which will then go for every bit in the chunk type, and then print the individual bit to the string. And an easy way to work with strings is you can either use the function append on the string object, or you can just use the plus equals operator to append characters or other strings as well. At least with the stl string that works this way. With many other strings as well, but I'm sure you will find some string implementation that does that behaves differently, since there are arbitrary many there.
Just create.
Mhm.
I need to get a pointer of the first string in the array, right?
Well, you need to get the count of chunks in our. You need a loop that initializes a counter. So let's say int e is equal 0. Then you need a condition that e has to be less than the count of chunks, which you will need to find out. That would let's just look into the constructor so we can. I don't think you have a count of chunks function yet. And size was in what? If you scroll down, not in the header, in the CPP to the alloc function. Where was it? Alloc data. Yes. So we take a size and then we count. So here we have an example how to count the size of chunks. Actually, it might be a good idea to move this to an own function if you want. Not quite. You need everything from line 47 up to and including 49, since we want this mechanism to add 1 in case we have less than
Yeah.
the right amount of chunks.
This one also.
Yes. Okay, and one more thing. Well, actually, it's fine like it. It's you can leave it there. What I would do is I would put it as a static function as a member of cbigint. So if you can do that, that would be great.
Do they use some keyword for that?
Well, you just need to you need to do two things. First of all, you need to add the namespace, so you need to write cbigint ... before count. Yep. And then you need to go to the header file and define the function. So you can copy from here the function as you have it, yeah, until here. And then here, yeah, global. It doesn't matter. It can be in the protected section, yeah. Paste, and you need to write static in front of it, and remove the namespace because we are already in the class definition, so the namespace isn't needed at in this place. Rightio, perfect. Very good. So now we can first of all change change the alloc function to use this count function since we have it.
Oh.
That would be beneficial to use it. Yeah, that's good enough. And then we can also use it in our other function. One thing to keep in mind, which we haven't thought about, we just started programming, is in which order we want to add the bytes to the string, because we want the order to be right. So we can do it in any way and then just check whether the order is right, and then instead of append use prepend. I think the string allows you to insert it in front, or then later on change the loop to go the other way. But this is a detail that we can take a look into later on.
Do we have an access to this variable from here?
Hmm?
I think no. I think we should pass this variable, right?
No, size you need to get from m pointer, m underscore pointer. Yeah, you don't need to define it explicitly. No, sorry, it's m underscore ptr. It's suggesting to m underscore ptr. Yeah, there it is, this one, and it is the usize already. And just use this instead of usize in the function call. Zack. And you don't need to have the namespace here, so you can remove big and double point. It's fair. It's okay to leave it in, but usually you remove it if it's not explicitly necessary. Okay, and now we need our loop. Actually, we could do it the right way from the get-go. If I remember correctly, what we would want to do when going through the loop, you would want to go like not front to back, but back to front. So we would like to start with the last chunk and end with the first chunk. So yeah, exactly. You need to make it -1 since the count is already one index too far. And here it should be greater equal, since 0 is still a valid index. Perfect.
Like this. Now we append. I'm not sure about this.
Well, first we need a second loop to go for every bit of the chunk. We could of course try to use some STL function that converts a number to a already formatted binary string, but that's kind of where's the fun in that? So let's do it manually. With regard for others that will later probably implement the from 2hex function. If you absolutely don't want to make the inner loop, you can go with using some STL function that converts you the whole number in one go to a hex string and then just concatenate it. But here, since we want this to be as basic as possible, hence we call it a low-level C++ programming, we will do it manually.
Size of chunk?
Almost. Size of chunk times 8. Since the chunk is made out of bytes and every byte is made out of bits, and we want the bits, and since we always have 8 bits in pretty much any existing modern computer system, there were some very, very old ancient computers that, for example, had a length of 7 bits only, or 5 bits, or 12 for 1 byte. So the ancient ones were more diverse, but the modern ones, it's always 8 bits, and that's it. And yeah. Okay. Nice.
And we do it bit by bit.
Mhm. Bit by bit.
Ja, also mal nicht so niedrig. Ich will mich langsamer.
So we need to get a pointer to the beginning.
It's I think pointer arrow data, p data. I think pointer arrow p data. Yep.
Da bin ich mir erst so abwehr.
Plus J. Would it work like that?
Plus I first.
Nee, aber steht hier noch.
And now you need to extract the single bit. Now you need to extract the single bit from the chunk. So p data plus I is the chunk. Now we need to find a way to extract a single bit from it. Nope. The closing brackets must be before MPTR, or the opening bracket in this case. Have you an idea how to extract a bit, or shall I tell you?
I have no idea.
Okay, so you have these bit shift operators, which are like 2 times greater than or 2 times lower than operator, and what they are doing, they are making a bit shift. So they're shifting the entire pattern of bits in a variable by the amount of bits that you specify. So since you don't know how to do it, I will do it for you. So here we have our chunk. Then we want so at this point here, this is basically the pointer to the chunk. So it's its address plus its offset in the array. So what we want to do is we want to dereference this to get the actual number. And once we dereference this, we would want to bit shift it to the right by j, or maybe it's this minus j. We will have to check whether it's correct or whether we have inverted the bit pattern. So the way this works is it shifts. There is some noise in the background somewhere. So the way this works is it shifts the whole pattern of bits. I might quickly demonstrate it. So let's say if we have the bit pattern 1 0 1 1 0 1 0 1 0, and then we make bit shift this by, let's say, 2. Then what we get is it will drop the first 2 bits. It will copy the whole thing, and it will fill up it by zeros on the left side. And if this would be a signed number, and the first bit, as shown here, would be, so this is the unsigned case. And if we would have this a signed number, then if the first bit is 1, then it will fill up with 1s. And if the first bit is 0, then it will fill up with 0. So it wants kind of to maintain the number being positive or negative. Signed case. And since with unsigned we only have positive numbers, then it always just fills up with zeros. Right, so let's use it. So we have our number, then we shift, which we already have shifted it, so perfect. So now we know that the most right bit of the whole thing is the bit that we are looking at. So now we want to extract this single bit. So what we do is we make an AND operation with 1. So basically, okay, we don't have an example here, but what this does is if the first value would be 1, then so the first bit from the right would be 1, then the whole thing returns true. If the first bit is false, then the whole thing returns false. It ignores all the other bits. So we made this, and then what we can do is we can use the trinary operator, it's the question mark, to now put some character into our string. So if it's true, so the way the trinary operator works, so a trinary operator, oops, as condition question mark so we want to put 1 as a character into our string if the condition is 1, is well true, I mean, and we want to put 0 into our string when the condition is false. And why is it complaining? I thought that takes single characters. Okay, maybe it doesn't take. Usually it should take characters, maybe it just takes full strings. Yeah. I think the plus takes characters. Doesn't matter. As mentioned, there are so many different implementations of different string classes that it's sometimes difficult to remember which one uses which exact which one has which exact functions. So that's it. And basically the last thing we need to do is to return our string. So the next part of this assignment would be to try this function out in our main class. So to write a test case, fill it with some byte pattern or bit pattern rather. Okay, right. So sorry, you can have the mouse. You don't need the namespace, you only need the name because you will be calling it on the object that we have instantiated in main. So for example, you can call it on myInt3 dot or at the top here on myBegin, that's also fine. I think you can either paste it. You could use the I think up and down arrows once this menu opens to navigate through the suggestions that the IntelliSense gives you. Right. So now we should probably assign this to some variable. You don't need. It doesn't take arguments. It just prints the current big int. It's not a static function. So just we would now, as mentioned, we should now assign it to a variable. Yep, of this type. Perfect. And if we put a breakpoint in line 13, we can inspect. No, one further down, because here the line is not yet executed. Here, yeah. It will move the breakpoint one line below because you cannot technically break on empty lines, but it's smart enough that if you have a breakpoint on an empty line, then just moves it to the next non-empty line in the function it can find. Okay, we can run it.
Can I just output it? Can I just output it?
Yeah, that's also fine. Okay, it complains something's wrong. You can look on, you can make the lower window bigger and scroll up to see. Okay, I will quickly fix that. Where's the mouse? There's the mouse. First of all, I would like this to be docked again. It is complaining about the other function which we haven't done yet. That it needs a return value. So that was no mistake of yours. I would move this here that we execute the print so that we can see on the console what it printed out, and let's run it. And when we go to the console, well, it did something. And the question is whether it did the right thing. So what we would now want to is, for example, to initialize our, where's the stop button? So initialize our big int, not with a, well, not with this, but with something that we can, we will know the pattern for. So test1, I will just quickly move this to test1. Oh, that's just a normal int. And then I will make another thing called test2. Oh. Now I want a 64-bit int, test2. The reason why I want a 64-bit int is to have at least 2 chunks used in our test, because if we only do it for 1 chunk, then we would not know whether the chunk is right, whether the chunk order is right. We could of course go to the chunk definition and just reduce this to a much smaller type, so like to a char, or maybe a short, whatever we prefer. But since actually this probably is a good idea, although char is too small, I would like to test it with a short. If we test it with a short, we actually don't even need a 64-bit number, but let's still stick to it. So 0p 1, 2, 3, 4, 5, 6, 7, 8, and then we have 8 of those. Wait, so that was 4 of those. So this is a 32-bit number, probably. Looks like 32-bit. And if we add even more, that would be a 64-bit number. So let's now make some pattern. Should be random enough. And now we expect the output of our console to be the same pattern in the same order. So let's quickly try whether this actually works. And if it doesn't work, then what we will need to do is to check the order in. So to find out basically what optically we can see is wrong with our order, and then I already see that something is wrong because I think I started with ones, so or I just printed here instead of, oops. And we are not printing the 0b prefix, but this is fine. 0b. Okay, so that is highly wrong. Well, since we know that we are printing in multiples of 16, then let's select 16 characters. Should be this much, and see whether, wait, nowhere. Let's select 8. Then we probably have reversed, not just. Yeah, okay, so I think the chunk order I think is correct. What probably is wrong is the bit order, I mean. So we will just fix this by, well, we can do 2 things. Either we can run this one in reverse, or we can just make our mathematical operation here. I would probably opt for running this in reverse, as that should be faster. -1 is equals greater 0, and here minus. Because this way we have the same amount of operations as if we run it the other way around. But we save on an operation here with this j. So let's run it again. Suck. That looks much better. Well, does it? I think it looks perfect. Yep. Et voila! It's working. It's working perfectly. Cool. So that's that. Since we only have 20 minutes left, I don't think we would have time to implement the from binary function, so this we will do next time. Let's see what we could do in the available time. Well, I could give you some homework. Let's see on the thing. So if I give you homework here, so if I give you homework now, wait, is this already? Yeah, that's the second lecture. 1, 2. The next lecture we have time. The next lecture is a holiday, so you would have 3 weeks to do something. That sounds like a good enough plan. 3 weeks time is great. So what I think would be a good next homework assignment, especially given that you have 3 weeks time, would be to implement some mathematical functions on our big int. So let's add it here. What we want in total, I think, would be addition, subtraction, multiplication, and division, as well as what it's called, modulo division. So modulo division gives you kind of the reminder of a division operation, if you would do it. So let's quickly start with that.
Sorry.
Yes?
Shouldn't the holiday week be after the next week, like on 27th? Or?
Yeah, but no, the holiday is 25th, and you have always 2 weeks. So you have, well, you have always, it's not, the homework is not for the next lecture, but for the over next lecture. And the over next lecture is after the weekend. Sorry, after the holiday.
Okay, so we don't have on 19th, we don't have a class, right?
No, you have a class on 19th, you don't have a class on 26th.
Okay, I understood. Thank you.
At least that's what I find out. If I'm wrong, please correct me. But the calendar that I found says that next week is normal, the week after the next week is a holiday, and the third week from now is again a normal week. So let's look. And also, if you have troubles with the assignment, because that's like the I think most complicated thing that will be tasked for the Dingstar, for this class that we are working on right now. Then I think it's we will not look into solutions for a few more weeks, so we will have a bit more time to implement it successfully. Yeah, so let's start with that. And also, I mean, I could also kind of write the assignment for the over next lecture as well, if you prefer that, so that you have more time to look into it. Because it's all more or less the same thing that we want to do. We want to implement the basic functions to do mathematical operations. So the way we want those functions to work is they should return a new big integer object. Let's start with the simplest one, add. They should take whatever to add. So let's say a const big int reference other, or to add. And what they should do is they should do this operation with the current value stored in the current big int object. So let's quickly write them down. We have add, we have subtract, then we have the more difficult multiply, divide, and modulo. As you see, I just put the function body here. So if you implement it, you just remove the function body from here and put the function somewhere into the C++ file here, but I thought it's just nicer to have it here. And for addition and subtraction, this is quite simple. So you can we will look how well it works. So we might do those functions during the lecture, and those functions will be the homework assignment. So like those are the more complicated ones, since well, multiplication is not that complicated, but division is. And I would recommend to just Google for some already existing examples. So you can Google for how to do binary. So basically how to do multiplication using just normal mathematical operations on a, for example, for a microcontroller which doesn't have those implemented. there are a couple algorithms available with sample code, which you will need to understand and then apply to our existing case. If I remember correctly, the algorithm for division, the way it's implemented, at least the one that I like to use, it always gives you already both values, so modulo and division. So the ideal way of implementing is you implement a helper function, which then returns you as so you have a helper function. It doesn't have a return type. It just takes whatever values you want to feed it, and then it has two additional parameters which are used either as pointers or by reference to return the result of the operations. And you just for divide return the result of the divide, and for modulo you return the result of the remainder. Of course, if you want to implement it differently, it's up to you. As long as they work, they work. So let's write the assignment here. 12, 10, 23. I'll just write the ideal due date, since we would like to avoid any miscommunication. That's 07 11 2023. As said, probably later will be also fine, since I don't think we will look into those anytime soon. We'll first try to do those during the lecture maybe, and or look into one of you might want to show their implementation of this two functions that were assigned the last time. Okay, so multiply, comma, divide, comma, modulo functions. I think so we only take operation on the chunk data. Comma. So we'll take as value right. I just call those value other. I'll just call all of them other. That makes it simpler. Other, comma, new segment object of the object with the value, comma, data is no. And since we don't, and since we want to ensure that they will not be altered, we will define those functions as const. This means that if you would try to change any non-mutable value of this object, then the compiler will throw an error. And also the compiler will throw an error because we are not returning anything if you just try to compile it. So let's add just return 0 so that we have a nice placeholder. Zack. Okay, and since we only have 10 minutes left, I think the best thing we can do in 10 minutes is quickly add some operators for those functions. So since we would like to later be able to use those variables in a mathematical equation and not having to write like multiply, divide, etc., etc. I mean, you can, but that makes things more convoluted. So we just define a few operators that will just invoke our function. So big int operator asterisk, then we provide the same argument. And then we need a const, of course. We want this to be constant. Then a function body, which in this case just return multiply. Return multiply other. Oops. Return multiply other. Then we would probably like to do the same thing, to have the option to do this, to use this operator. This one works slightly differently. It is in fact altering the current object. It is not altering the other object. So the way we do this is just we assign to this asterisk the operation of multiply, and then we it is not const. You see it's complaining here because const has been specified, which we don't want since we are modifying this. And then we can just return sorry, this should be asterisk this one, not this asterisk. Then just return asterisk this. And then we can just do the same for the other operation. So division is trivial. Divide. And for modulo it is customary to use the % operator, which yeah, will invoke our modulo function. Okay, and since we are at it, we already could do the same for plus and minus, why not? And as said, we'll probably look into plus and minus during the next lecture, or we will look into some other operators which are also easy enough to implement. Add, subtract. Yeah, this we have, and just maybe for completion, well, we will need quite a few more operators. So we'll also need to let's write it quickly down. Bit shift operators, comma. Let's call it bitwise. Bitwise operator. So if we want, if we want to just make an AND on or etc. So this we will need to implement as well. And what we also would like probably to have would be comparison operators. So we only have an assignment operator, but we would like to be able to also compare if two numbers are the same or if one is greater than the other. So there are quite a few other operators which we will want to implement during the course of this lecture. Yes. Yep. Any questions? No questions? Okay, if there are no questions, then since we only have 6 more minutes left, I think we can stop at this point. You have enough to do with finding out how to do multiplication, division, and division on the thing. Yeah. Yeah, so yeah, since there are no questions, then I would say have a nice weekend, and we will see each other next week. Bye bye.
Thank you. Have a nice weekend.
Thank you. Bye bye.
Thank you. Bye bye.
Thank you. Bye.